Okay, fine. So we are going to continue the join operation which we had discussed a day before yesterday. I mean in the last class. So I'll continue with that. Today we will be discussing various forms of the join. There are many forms of the join, and I'm telling you the join we have exercised up to this point is actually the equijoin. Is actually the equijoin, which is another form of inner join and is a special form of theta join. What are these? Inner join, theta join, outer join, and then natural join, and then uh, other joins. Today we are going to make it clear. Okay. So first thing I told you that whatever we have exercised up to this point was actually the equijoin. How was it equijoin? Because the condition on which we are applying the join operation was equality. For example, okay, so as usual I'm activating the database, sales database we are using, and we have many tables within this database. Today we will be mainly operating on the four tables, and their name are EMP, status, salary, and X salary. Okay, these are the four tables we will be operating on. X salary actually is the copy of salary with the changed column names. Select a star from sorry. Select a star from X salary. You would be noticing is it is another copy of the salary table, but the column names are different. Whereas in the uh, salary table the we are having the columns ID and then ES code. Here we are having E code and then ES code. So this we will be utilizing when I'll show you how can we join on the columns which do not share name in the tables. Okay, so first of all I'm going to uh, take into account a very simple join which we have been constantly exercising. Select emp.id comma emp.name comma salary dot s code from emp join salary on emp.id equals to salary.id, and here is the result. Right, I've already told you it's an equijoin. Why it is equijoin? Because the condition of joining is equality. emp.id equals to salary.id. For instance, what happens if I change this condition to greater than to greater than? Look at this. What is the result? So to make it more clear, I select another column Here it is. Now every ID appearing from the salary is less than the ID appearing for the EMP table. Here we have joined them conditionally. What actually a join is? Who is going to tell me? If I ask you to mathematically express a join operation, what would be your answer? I want to ask how relational algebraically we can define the join operation. Can anybody tell? Hello. As usual, all of you are lost once again. If I ask you what a join relationally algebraically is, who is going to tell me? How do we define a join operation in the relational algebra?
So it is simply a cross product of two tables
Cross product
followed by selection or condition.
followed by a selection based on a condition. Exactly. That's a join is. We cross product two tables and then we choose the appropriate rows which satisfy a condition. Here the condition is employee.id is greater than salary.id, and this seems to be satisfied here. 103 is greater than 101, 104 is also greater than 101, and then 104 is greater than 103. So when the condition of joining is other than equality, it is called theta join, and it is the most general form of the join. You got this? When the condition of joining is other than the equality. For example, I have executed this statement for the greater than condition. If I change the condition to less than, then look at the changes. All the IDs from employee table are less than the IDs from the salary table. If I make it less than or equal to, then see how it changes. All the rows where the condition equal to is satisfying is also there, are also there. Sorry. If I make it not equal to, all the rows are there where IDs from both the table don't meet. Okay, so whenever I have executed a join without a condition other than the equality, actually I have executed a theta join, right? Condition can be equality in theta join as well, but in that case that becomes a special case of theta join, and that is called equijoin. That is what we had been exercising since the beginning. Okay, you got it?
Yes.
So when there is a condition, it's a theta join, and when the condition is equality, it's the equijoin. This is the slight difference between uh, theta join and equijoin, right? And in other words, we can say equijoin is the special case of theta join when the condition of uh, comparison is equality. Now we move on to the natural join. The concept behind natural join is that if two tables are having, sorry, but before proceeding to natural join, I would like to tell you another thing. Look at these two tables. Those tables are select star from EMP, right? Now I say select star from Accelerate. Notice the column names. No column name is common among these two tables. The first table columns are ID and name. However, the columns from the second table XLRE are E code and ES code. Okay. The $1,000,000 question is, can we still join them? And the answer is yes. See how. Select star from, select ID comma name comma xsalary dot es code from emp join on join xsalary on emp dot id equals to e code dot salary dot xsalary dot e code. Do you think this statement is going to be executed? The answer is yes. Have a look. It's giving us the same answer. The answer we had received when we had used salary table instead of X salary table, and in salary table the ID was the same column which was there in the EMP. Okay, means they were sharing the same column name. Here the column names are different, but we are still able to join. Why? That is because of the real spirit of inner join. The real spirit of inner join. Now you ask me what inner join is. Inner join means theta join, equijoin and the natural join. Theta join and equijoin I have covered, but natural join I have not covered yet. For these two inner joins, which two inner joins? That means equijoin and theta join. For equijoin and theta join, the spirit of executing join operation is that the name of columns may be different in the two tables, but what should be common? The common should be the domain where from the two columns are picking their values. In these two tables, I mean from employee table and the salary table, both the attributes, that means ID and E code, pick their values from the same domain. Every E code is a 3-digit integer. Similarly, every ID is a 3-digit integer. That means ID and E code, though they are not sharing the name, that means they are not having the same name, but they are picking their values from the same domain. That means they can be equijoined and they can be theta joined. They cannot be natural joined. I'll come on the natural join after this. They can be theta joined, they can be equijoined, but they cannot be natural join, because in natural join we don't specify the condition. Natural join automatically assumes that certain columns are common among the table. Their name are common, their values are common. Okay. So even if I want to execute a theta join, I can do it easily. Here it is. I have changed the condition from equality to greater than, and it becomes the theta join. Okay. So always remember, there are three forms of inner join. Number one is theta join, number two is equijoin, and number three is natural join. As far as equijoin and theta join are concerned, they can be executed on the columns which are not having the same names in the two tables, but the spirit of joining is that both the columns must pick their values from the same domain. Which both columns? The columns on which the join operation is being carried out. Okay, like we have done it with the join command, it can also be done using the where clause. See how? From emp comma xsalary, where and there is the answer, the same answer we are getting here. And if I want to execute theta join using the where clause, it's here. So always remember this thing. Is it clear to everyone? Please respond. Is it clear to you?
Yes, sir. Yes, sir.
Okay, now we proceed on to the natural join. In natural join, we need not to specify any condition. Natural join automatically assumes that there are certain columns which are common in the two tables. Okay, and when I am saying which are common, it means their name are same, it means their values are uh, in one column, in one table it's the primary key, and in other one it is the foreign key. So their values satisfy the referential integrity. Referential integrity means the value of foreign key is either the same as of the primary key or is purely null. Okay, so it's very simple to execute the natural join. For example, sorry, CLS. For example, I want to execute natural join on the tables emp and salary. These are the two tables, one is emp and another one is uh, salary. You would be noticing the id attribute is common, its name is common, its values are common. Okay, so these two tables can be joined naturally. How? See, select emp.id comma emp.name. I could select salary.id, but I wouldn't like to select that because the spirit of natural join is that only one copy of the uh, common attribute should be there in the final result. So emp.id comma emp.name comma salary dot salary dot scode, ठीक है, from natural join is the keyword. The name of the other table is salary. Now there is no need to specify the condition because natural join automatically assumes that columns are common in the table. They are sharing a common column. Plus the condition of joining is always the equality. Here is the result. However, if we try to execute the same operation with the X salary table, which is not having the common attribute name or common column name, we can't do that. Then in that case it will give the error, because in one column the name is id, sorry, in one table the name of the column is id, while in the other table the name of the column is ecode. I will not even try that because that's the utter nonsense. So I cannot give the condition with the natural join. So I cannot specify emp.id equals to xsalary.code with the natural join. We never give the condition with natural join. The condition is automatically there. Okay, this is how we can execute the natural join. So now we have covered our inner joins. Inner joins means three type of joins. Number one is theta join, which is the most general. Number two is equijoin, which is the special case of theta join when the condition is equality. And number three is natural join, where we don't even specify the condition. Right? Now we come on to the outer join. What do we mean by outer join? Inner join means all the rows where the condition we were specifying gets satisfied are there in the result. Right? Outer joins are executed where there is a mismatch between the value of the values of the attributes on which we are joining. For example, look at these two tables. Select star from EMP, and now there is another table. Select star from status. What is the name of the table? Show tables. It's E status. Select star from EMP. These are the two tables. Look at the values of ID in both the tables. In first table the values are 101, 103 and 104, but in the second table the values are 101 and 107. When we will be joining these two tables, we will be getting the information that Jones is a clerk because IDs are meeting, we know. Okay, but what about the status of Smith and Yvonne? Similarly, where the status engineer should be assigned to. Okay, certainly their status are unknown, that means it should be null. Okay, so we have a situation where the column values from one table do not meet the or do not uh, meet the values of the same column in the other table. In this situation, we execute the outer join. Okay, the join we have exercised up to this point, that means all the inner joins, no column was having the null value, but it's not the case with the outer join. This time we will be joining and some columns depending on whether we left outer join, or we right outer join. Depending on whether we left outer join or we right outer join will be having certain null values. Okay, say for example, select employee.id, employee.name, eStatus.id, comma, eStatus.status. From eStatus, left outer join, emp on eStatus.id. What I have done, I have executed a left outer join while joining these two tables, that means emp and status. Always remember, with left outer join, the table that is existing on the left side of the left outer join, which one is that table? E status. All rows from E status will be there in the result. That means the two rows which are supposed to be there are 101 and 107. So the result would be 101 clerk and 101 here is meeting 101 clerk, and it will be meeting here 101 Jones. So answer would be 101 Jones, 101 clerk. Next, the answer will be null, and then 107 engineer. Look at the answer. Here it is null 107 and engineer. What has happened here? All the rows from the table which was residing at the left hand side of the left outer join have appeared in the result, and the columns of the other table which were not meeting with the values in the e status table have been shown as null. Okay, you got this? Is it clear to you? Hello?
Yes, sir.
Yes, sir. Yes, sir.
Okay, now I execute a right outer join. In right outer join, what's going to happen? All the rows in the table that is going to appear at the right hand side of the right outer join operation are going to appear in the result. So if I make a slight change, and what is that change? The word left, I change to right, then all the rows appearing the emp table, because emp table is residing at the right of the right outer join operation. Okay, all the rows from emp table are going to appear in the result, and the rows of the e status table which will not be meeting the values will be filled with null. Look at this, here it is. This time instead of 2 we are getting 3 records, because there are 3 rows in the table emp which is residing at the right hand side of the right outer join operation. Okay, so these left and right outer join are actually the left and right outer equijoins, because we have specified the condition as equality. Could I change the condition to greater than? Here is the result. Yes. So this time I have executed a right outer theta join. Okay. Similarly, there can be left and right natural joins, provided the certain columns in the table are common. For example, here is the id column. So outer join will naturally join on id, and the condition would be equality, but I will shield from specifying this condition. Okay, see how can I execute a natural outer join. Natural left join. What is the name of the other table? emp. The answer is same, which we had received with the uh, left outer join. But the advantage here is that I need not to specify the condition. The natural join I am able to execute because the attribute names are same. If they could have been different, and if they were different, then I was forced to execute the equi join or theta join according to the condition. Similarly, natural right join I can execute like this. I'll get the same answer which I had received with the conventional uh, right outer join. Here it is. Okay, and here's the end of this class. In the next class, we will focus on few more properties of the join, and then we will be skipping on the subqueries. Okay. Thank you very much. You want to ask anything? Hello. Do you want to ask anything?
No, sir.
Okay, fine.